Welcome to the We Hack Purple podcast, where each episode we meet someone new from the information security industry. And this season, season 3, is all about securing software or application security. I am your host, Tanya Jenka from We Hack Purple. And this episode is sponsored by Semgrep. And we'll hear a little bit more about them partway through the episode. But you're probably like, Tanya, come on, just tell me who your guest is. So my guest is Isabelle Mauny, and she will say her name a lot better than I will. Welcome, Isabelle.
You did well. Hi, everyone. Isabelle Mauny. I'm the Field CTO at a company called 42 Crunch. And, this is all about APIs and security. So that's mostly what that episode is going to be about. It's going to be about APIs and security.
Yes. I met Isabelle years and years ago in Britain when I gave a workshop about API security, and she came up to talk to me, and I didn't know that moment would be so important over time as I got to know her over many years. And so I'm so glad that you stayed after and talked to me. Thank you. And so what are APIs? So just if you're listening, you're like, oh no, is it that level? We're just doing 1 minute of intro and then we're going to jump into the topic.
Sure. So what are APIs? Well, basically, if you don't know, you're probably using APIs every single day of your life. You're looking at your bank account on your mobile phone, you're using APIs. You're talking to friends over WhatsApp, you're using APIs. So what is it? Simply something we can talk to or ask for information, or we ask it to execute something for us, and it will return some data, or it will return, information like the list of our bank accounts if we're talking to our bank. So just a place we talk to and ask them to do things, pretty much.
Yeah, that's actually a really good explanation. I really like it. That's I say almost the exact thing, so I'm like, oh, awesome. And so
Yeah.
then what is API security? It's super fashionable right now, but what is it really?
Well, let's say, the problem. So going to what we just said, what is an API, right? So an API is something you talk to, you ask it, you send him some information and send it some information, it giving you some information back. And they're really pervasive. Like really, it's something I think is one point everybody has to, think about is wherever you are, whatever you do, if it's in healthcare, if it's in IoT, if it's in banking and insurance, wherever you are, APIs are involved. So in terms of the surface attack and security, this is really emerging as, well, the problem pretty much in application security because of two things. So if I can just give some background before
Yes.
diving into security itself, but there's really two things that are impacting why API relevant security is so relevant and APIs are such a problem. And the first one is, how we changed the way we are writing applications in the past 5 or 6 years, right? Before, what we used to do is we wrote this like monolith big application that will all be running in servers that we would be running, that we'd be protecting, and the access to that was like kind of limited, but whichever application we will write on top of this, it's kind of a closed world, right?
Mhm.
But the evolution of that over the years has been to open that world more and more.
Mhm.
To allow third-party people to integrate with each other, with us on many different fronts, right? So to give you an example, of course, we all lived COVID, etc. One of the big accelerators of the transformation of the healthcare industry has been COVID. Why? Because certainly everybody wanted to see their doctors over a phone and a mobile application. So we all had to scramble and write APIs like crazy so we could create mobile application and actually, do that. Now, that's the first transformation, is an architecture transformation. And this is going hand to hand with another transformation, which is, of course, the cloud. So that we're going to a distributed architecture, something which is like, instead of having our monolith that does everything, we're kind of exploding that into multiple pieces, sorry, more than places, so that we can, well, I don't have to manage whatever a Postgres database anymore. I can go to a cloud provider and they will that for me. And so I don't have to worry about this. I just have to worry about my own logic, for example. And so we're taking this thing, we're exploding it into whatever 10, 20 different things that are talking to each other. And guess what? How do they talk to each other? Through APIs. So now we're not only using APIs to exchange and talking to the outside world, we're also using APIs to have all those, pieces of application, microservices, right? This is where the microservices world comes in, talking to each other as well within our enterprise. So most of customers I'm working with went from having 10, 15 APIs to having hundreds, thousands because of those two transformations, right? So that surface attack is just humongous. Therefore, the problem with security and why we have to worry about it, right?
Yeah, I feel like the attack surface of an organization has become not necessarily way bigger, but way more complicated. Like
Completely.
there's so many pieces now, instead of one big target, there's hundreds or thousands of targets.
Yeah,
And they just
yeah.
need to get in once. Like anyone that's a goalie will tell you, like, oh yeah, everyone freaks out because one got in. Well, what about the 500 I blocked throughout the game? Defenders have a hard job.
It is a very hard job, and it is, when I frame this in conferences, I take this image from a middle-aged type of cities where you had all those walls that were built around the center of the city, and you had this one entrance, right? But that was like super defended. But around it, you had all those walls, exactly what we were doing before. We were building, firewalls and, application firewalls, network firewalls, all kind of walls around our companies to be able to protect the heart of our company, right? And every time we open an API, as I tell to people, it's like you're punching a hole within those walls. Like you're letting people get straight into the heart of your system. So instead of protecting this one door, you have to go around and look at all those different holes you're opening, and we never stop opening new holes, basically.
I
Right.
used to have a boss who referred to our firewall as the Swiss cheese. And and
Yeah.
all my friends from Switzerland are like, that cheese with the holes in it, that is the least tasty of all of the Swiss cheeses. We have so many better, and it's true. They have amazing cheese there
Let's
and
not
good
get there.
firewalls.
Yeah.
So, okay, so everyone's like focusing on how we need to secure APIs. These are important, we know, but it's not going well for everyone. So what might be, so this is a big question, but what's going well and what's not going well? And I don't expect you to define everything, but what are some examples of things going well and things not so good?
Well, the first thing I would say is I think companies came to the realization of what they had in place for traditional application security does not completely apply or does not apply at all, depending on what they do, to the world of APIs, right? So the typical web application firewalls that are really in front of our apps, the typical, looking at code analysis and things like this. So there's some stuff it's going to catch, but we need also some tools which are specialized in APIs and understand APIs. And let me give you, some examples. So at some point in time, this is a security talk. We need to talk about OWASP, right? So in when we started our company, it was back in when we met in 2016, 17. We had to fight with people to convince them that API security was a problem. Everybody was like, no, this is like an app. It's just the same thing. No problem at all, right? And it took all the time. And actually, it took the OWASP top 10 for APIs for people to say, oh, there is a top 10 for API. So then, that must be different than the OWASP
It
top
must
10,
matter.
right? It must matter. Something is wrong here. And that was really the click. It was like the thing that suddenly everybody says, oh, so there is something special about APIs. Bing, right? So what is special about APIs? And the first main thing is really about data, right? So as I said at the beginning, what is an API? An API is something you ask it for some information, or you ask it to create something from information, and it returns information. So you're constantly sending data, receiving data, sending data, receiving data, right? In the traditional AppSec world, we've been very, very focused on looking at what comes in, because that's usually where the problems are coming in, the attacks, the injections and the scripting and all this cool stuff, right? It's on the requests. Now, with APIs, there is a new problem, which is to look at the data that goes out. Because most of the breaches around API, they're about extracting data and
Okay.
letting data we didn't want to let go out, right? So zillions of records, right? So that's where the traditional AppSec tools come short. Why? Because traditionally they never looked at responses. They always looked at the requests to
Yeah.
start with. And second, they don't understand the fact that, okay, so I have a response that has a first name and a last name. Oh, that's strange. Somebody's extracting something called token. A traditional tool will say, okay, that's a string. Does it contain an attack or an injection? No. Okay, I'm happy with that. All right. So, in order for a security tool in the API world to be efficient, it needs to understand the context in which it's looking at the data. And understand the context, by that I mean is, well, there should only really be a first name and a last name. Token has no business being in that response here, for example, right? So that's the first problem, is that people just looked at it. No, so we don't have all the tools for doing the job. The second one is, again, because of that change of architecture, what we're doing now, if I'm writing a mobile application, I'm writing a web application talking straight into APIs, what I really do is I ask that API for some raw data, like in XML or in JSON, and it's usually within the app on the client side. Then I'm going to look at all that data, massage it around, decide that, okay, I need 3 things out of the 50 I have retrieved, and I'm going to display that to a user. But if I go straight to the API without going through the client that filters and messages the data and everything, well, I see the raw data in JSON, right? And this is where people don't control enough that information, that
Yeah.
it leaks a lot of information that we don't see if we use the app because it's been removed by the app. But if you
Yeah.
get straight into there, then you actually see it, right? And this is, a key problem in terms of leakage of information, which is like in the top 3 of the API top 10, right? Um, so it comes to tools, it comes to threat modeling of APIs and understanding, it comes to understanding the sensitivity of the data that we're
Yeah.
actually manipulating through APIs. So there's a lot of moving parts around understanding what it is we're building, and putting the right security measures in place for what we're building. So it's not the same to write an API that returns, as I always say, the weather channel, right? And I put the name of a city and it returns me the weather in that city. Okay. Could this be sensitive data? Maybe. I'll give you an example right after. But probably not, right? But if I do a transfer of money between account A and account B in a bank, that's a very different story, and the security measures cannot be the same for those two things. I need to evaluate that. So we have, I think, traditionally written APIs too fast, and we have not designed enough the security around it.
Yeah.
And now we're really paying for it. Like all those breaches and all those problems, they come from the fact that we just jumped into writing code without really analyzing the consequences of the authentication, authorization, and data control measures that we had to put in place. All right, that makes sense.
No, it makes perfect sense. When I started as a pen tester in, I think it was like 2016, I was a pen tester for like a year and a half, not very long. And then I switched to AppSec because I kept doing AppSec at our
Mhm.
customers. And my boss was like, what are you doing? Why does this take so long? But then everyone asked for me. Anyway, I digress. I remember doing a pen test on a mobile app. And in the scoping meeting, I said, oh, okay, so are all of these APIs in scope for this test? And they look at me like, how did you know about those? Those are a secret. APIs are invisible. I'm like, oh, I just took this web proxy and I just proxied the front of your mobile app. And then I saw all these calls and I just wrote them down. And they're like, she hacked us. I'm like, no, 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 no. And by the end of the meeting, I was hired, but still under suspicion. And I was just like, oh my gosh, if they think they're invisible, Isabelle, how do we explain to them they're not invisible? We need people. Do you feel like that's changed since 2016? They know now that they're not invisible, or there's still some devs that are like,
Well, I still have to explain. In general, I refine the what does that mean to have a public API. People have this huge misconception that public means I have a developer portal and I'm advertising my API and it's somewhere public and Jodo can come and consume it. That's a public API in people's eyes, right? And that's like, no, no, no. The minute it's on the internet, it's public, right?
Yeah.
And even that's the other thing I think people don't realize. So there was this interesting so it's a ethical hacker who actually found the problem, but there's this brewery who had a problem about a year ago or so when basically what the pen testers did, ethical, what the ethical hackers more than pen testers, what they did is they just took the Android app and just very, very easily decompile it. That's extremely easy to do. So anybody watching here, this is not magic. It's like 3 lines, and it's very easy for anyone, including you, to actually do that. You get the source code, and once you have the source code, any hard-coded thing, all your APIs are absolutely public, right? And what those guys did, they hard-coded the API token to call all their APIs within the app, right? So you would log in, it would create a token, they will totally ignore it. They will just always use exactly the same for every single user, every single call, right? So, well, don't do that. That's a bad thing. And if you
Free
hard
beer.
code something in your code, free beers. And you know why? That's how apparently they found that there was a problem, because the guy who found the problem basically said, okay, I'm not going to say anything, but probably under the dark web say, listen, you want to get free coupon for beers? Just make those API calls. That's the token. You can get some coupons and get some free beers. So the coupons probably, number of calls went like, and that's how they find out somehow. But yeah, so that's a key point. Anything you want to try this, any machine, any API, anything you put on the public internet, 5 seconds later, you have bots hammering them with things. That's it. Just start a machine with a virtual machine with root admin123 as the password. Then you'll see what happens.
Yeah. And it will be
Yeah.
bad.
And it will be bad. Just for the sake of having fun, and then you turn it off, right? But that will give you the idea of how fast those things are actually discovered and hammered with all kind of metasploit, and it's very easy to do.
So it's not just me, everyone. Isabelle agrees. The moment you put it on the internet, it's no longer safe.
Yeah.
So, okay, so a big topic that's like all marketing people are using this term, but it actually means something, DevSecOps.
Hmm.
What is DevSecOps for APIs? Like, is that a thing that we can do?
It is. It is. So, and this, so for me, there's like three main motivations to actually automate security as part of your DevOps API lifecycle, right? So starting from dev all the way to production. And I see this at every single customer that I work with. The first one is the sheer number of APIs that people have to work with. So, as I said at the beginning, people had 10, 20, right? And maybe manual testing somehow, could somehow work, right? I'm not even sure 20 is the right number for it to work manually. Probably not, right? But when you have 100 or 1,000, forget about it. Knowing, and I'm sure you've seen that in every company you work with as well, Tanya, is for the 100 developers people have, how many AppSec people do they have? 2, 3?
Oh,
That's for
less.
the rich people, probably, right? If they can find them.
GitHub says it's 500 to 1 now.
It's crazy, right? So please get empathy for the poor AppSec person who is sitting in front of 500 API developers who are hammering like crazy code all day long, creating new APIs, updating existing APIs. So there's no way you're going to catch up and do testing of those APIs to discover that they have problems unless they are automated, right? So putting in place some kind of tooling which allows you to evaluate, hey, you have potential vulnerabilities there. giving the developers the means to reproduce those issues very easily from within their IDs is very keen to me, because I think one of the main problems as well with this, a lot of security tools, is they're very AppSec people focused. They are not made for developers.
Mm.
And it's really hard for so the developers already have a lot on their plate, a lot. And now we're telling them, okay, shift left, seek DevOps, there you go, security, boom, that's for you developers. And they're like, whoa, hang on, like before testing was already done by others, now testing is also done by us automatically, and now security has to be done by us. And of course, nobody's giving them more time, because that's the other thing, right?
Yeah.
So same amount of work, or so same more work, sorry, with the same amount of time. That's not going to scale, right?
Mhm.
So it is very important, considering the number of APIs and the number of people we have to actually do the work. Your only salvation is basically automation, right? And introducing all the security things step by step within your API lifecycle, starting with the most important ones. You're not going to do this in one big bang. It's going to be too much. But
Yeah.
this is also where threat modeling and knowing your APIs is very important. It's like, where are you going to start? If I'm telling you, you have 1,000 APIs, what are the 20 ones, let's say, which will be really problematic if tomorrow you have a problem and you come out on the news, right? Start
Oh,
with
yeah.
those, right? And know what they are, the data they're there, automate the security for those, make sure they're just fine, and then learn from this, and just grow the process in the rest of your API step by step. So that's really important, and we also need that because of some specific tests that have to be done, I think, on top of APIs. That would be very easy to do if we were doing them very early, but become very complicated as we wait and we advanced in the life cycle, right? I'll give you an example. I'm sure we're going to talk about authentication and authorization and this kind of stuff. But the number one problem in APIs today is something called BOLA, okay? Broken Object Level Access. For anyone here who's been, around the block before, you may have heard of IDOR. In the end, it's all about the same story, which is a problem that you get a reference to a resource, and we're not doing a good job at validating that that resource is accessible by whoever is asking access. So if we take an example here, for Isabelle and Tanya, I have a bank account. My bank account is 123. Okay, so I log on to the bank. I can access account 123. When Tanya, we're in the same bank, who knows, right? If she tries to access account 123, she can't do it. So she still has the right to log into the bank. She has the right to call the operation that's kind of get account details, let's say.
Mhm.
But she can do that with her bank account, not my bank account, right?
Mhm.
Sorry about that. This is the store coming. So that's BOLA. Now, this is a pure but complex authorization issue. So we basically need to ensure
Mhm.
through testing that when we write this functionality, indeed we do automatic tests to log in as Isabelle, access account 123, logging as Tanya, access account 123, and the second call should fail. And we have to automate that just to make sure it doesn't come back, right?
Yes.
And we have to do this early, because we get at production level, we do a pen test and we discover that problem. It is going to be so expensive and difficult to fix. It's going to be really, really complex to fix, right? So we just need to, earlier we do it, the best, Are you convinced you're going to put
Oh,
DevSecOps in
I
place?
am convinced. Oh, yeah. Like I teach this in the secure coding. Absolutely. And explaining to like a junior pen tester, okay, we're going to make a racy chart with like every single different type of user and every single different permission, and you're going to log in as each one and try to do all the stuff you shouldn't be able to do. And they're like, that's going to take forever. I'm like, yes,
Yes.
it will. And that's one of the reasons I'm not a pen tester anymore, because patience is not one of my virtues. You have to be such a patient, thorough person to be a good pen tester. And I'm like, no, 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 I need to automate everything. I'm out of here. So
If only because, again, it doesn't scale for So I'm saying even 10 API doesn't scale because you have so many combinations
It's
of all the
true.
operations and what you can do on which piece of data. I mean, it's going to be hard enough to define this, like what are the use cases and write those tests, than having to just generate those automatically as much as you can to find something that does that for you. Go for it. It's very important.
Yes. I also explained that getting a pen test for every single app and only ever verifying your stuff with pen tests is the absolute most expensive way. Actually, it's the second most expensive way to do security. The first most expensive is to just have a giant breach and then start your security program, which a lot of companies opt for. You and I were against that plan. But yeah, so very briefly, I need to thank our sponsor, and then I have literally 27 more questions I want to ask you, and I'm going to have to prioritize them.
Okay.
Oh, very special thanks to the sponsor of this episode of the We Hack Purple podcast, Semgrep. Semgrep Supply Chain Reachability Analysis lets you ignore up to 98% of false positives in open source vulnerabilities by quickly finding the 2% of issues that are actually reachable. Get your free trial by going to semgrep.dev/products/semgrep-supply-chain. Semgrep also makes a ludicrously fast static analysis tool. It's fast, I've used it. They have free and unpaid versions of this tool, which uses an open source engine and offers additional community created rule set. Check it out by going to semgrep.dev products/semgrep code, or just go to semgrep.dev and you will find all the magic. That's how I find it. I don't click I don't type the whole thing in. I just go right to their site. So thank you, Semgrep. But back to you, Isabelle. I have more questions. So
Sure.
APIs used to be SOAP, and I used to use SOAP UI to test them, and I was a sad person. And then OpenAPI came. And so can you tell us what OpenAPI is and what role it plays?
Yes, I can. I have two hats here. I have my 42 Crunch hat as Field CTO and my hat of the chair of the Open API Foundation. So basically, think of this as a way to describe the contract of an API, right? When you're writing an API, what you're really defining is, okay, this is how you can call me. This is the path to call me. Those are the verbs you can use. This is data I'm expecting in. This is the data I will return to you. This is all the different errors that can come back. And you can really very thoroughly describe all those interactions through this API in a static, descriptive way. Okay, and it's taken. So originally it was created as, and it's going to be resonate with maybe more people, something called Swagger, which I have to say is a more sexy name than OpenAPI. Um, right, but this is taken. It's a trademark from our friends from Smart Bear, so we cannot use it as part of OpenAPI. But it's really the same. So Swagger 2.0 basically is the same as OpenAPI 2.0. Smart Bear donated the specification to the OpenAPI Foundation a few years ago now, and that's why it's called OpenAPI now. And at the beginning, it was all really about documentation, right? Because if I'm writing an API and I'm going to use the word open as opposed to public, which really means that I'm creating an open API that is going to be openly available to partners or even any third party who wants to consume them. And of course, I need to tell them and describe to them what it's going to do. Because otherwise, I will have to be on the phone with people all day saying, okay, how do I call your thing? Right. So, okay, we write documentation. Now, because it's extensible, and really it's being used everywhere, it's growing really much beyond documentation now. There's actually a lot of security things around open api. Well, we do some things around it in terms of doing security analysis of your apis through open, just by looking at the open api definition, because here what do we describe how it is secured. What is it using? Is it an API key? Is it OAuth? Is it basic authentication? Is it over HTTP, over HTTPS? The format of the data, is that data constrained, etc., etc. So we can start, like, even with no code written for that API, to start giving you some feedback about the security of your API. But it can also be used to do automatic testing. Some, WAFs are even using that now to configure themselves. There's, of course, generating mockups. I mean, there's a huge ecosystem around Open API now. So if you want to see all of them, actually, there's a site we've created very recently, which is tools.openapis.org. Okay. If you
Mhm.
go there, you will see all the ecosystem around the specification, and you will see there's like tons of different things you can do with it, whatever your role.
We are going to put that link in the show notes if you're listening, because
Yeah.
I want all of Isabelle's links. I want all of the knowledge that we can get from her on our website as soon as possible.
Sure.
Okay, so how do we make so I have long touted that software developers do care about security. It's that they also care about all their other priorities. And if their boss says do this instead of security, their boss pays them. Their boss
Mhm.
decides their performance review and if they get a raise or if they get fired. And so I respect doing what your boss says.
Mhm.
But a lot of people say developers don't care about security, and I disagree. But how do we spread this culture? The APIs need protecting too. They need to be protected. Just they have the same value of a web app potentially, right? And so how do we get them to listen or pay attention?
Well, essentially, so first of all, I totally agree with you. The same way no developer wants to introduce a bug in their code because that's going to come back in their face to slap them, much stronger than the first day they introduce it. It's exactly the same for security problems, right? It's going to come back to hound them. So they don't want to introduce such issues. But again, I'm back to what I was saying at the beginning. I think the problem right now, for many years, and this is changing now. I think SNCC has been initiating some years ago that movement of saying, well, you're not going to scale security if you only care about the security, the AppSec part of the house. The people who are really doing the work here and we're writing code every day are the developers. So you need to give them tools that they can use, that they understand, and educate them. And this is a key thing, right? It's like, how do we educate? We have to invest in educating people on, on that line of code you wrote there. It is, not good because of A, B, and C. And people are not
Mhm.
stupid. If you tell them A, B, and C are that's the problem. If you write this is what happens, right? Then they say, okay, right, okay. Well, they'll maybe do it twice, and then third time they say, oh, that's right. I write this happens, so I'm not going to do it. So we need to invest in education, but also we need to have those tools that just sit within the developer's flow. Again, and I'm writing code from time to time, and I hate to go out of where I am. So I'm in my IDE. I'm writing some code, and I want to have kind of instant feedback of some things that I'm writing, much like you're compiling, your code, and you instantly see, boom, that line is wrong because that's not the way it's spelled or whatever it is. Well, I have something that pops up right there that tells me, hey, this thing you're written, that's exactly what we do for Open API files. That's going to come back and haunt you if you don't fix it, right? Or just
Yeah,
click on the button and say, okay, do security testing against my API and get some feedback. So we need to educate, but we also need to give them the proper tools to be self-efficient,
yeah,
right? And as much as possible, this is what I hear from every single developer I talk to, false positives. People hate false positives, right? Because you have those tools that just give you 10,000 errors, and then 9,000 of those are actually false positives, and it's kind of your job to comb through those and discard the 9,000 you don't want. That is not going to fly well, right? So whoever listening and you're choosing tools, make sure that those tools work well for your developers. Otherwise, again, you will have a scalability problem for security. For APIs and apps, it's true of both, by the
oh
way.
yeah, I
Yeah.
completely agree. Isabel, in 2021, I scanned an app. So a company I had a contract with, they bought another company and they're like, can you just give it a quick scan? Isabel, the tool that they chose, not me, said there are 43,000 vulnerabilities in one web app. One web app. I was like,
That can be.
it was
Yeah.
so
Yeah.
okay. But I want to ask a positive question. And so please feel free to remove any sensitive information. But you've been
Mhm.
working with customers on API security for many years now. And you've been doing it like since before a lot of other companies started to pay attention to this.
Yeah.
What have customers been doing to have like to enhance their security posture for their APIs? Like things you can share, obviously, like don't break any NDAs, but like positive stories of how they're turning things around.
Sure. Yeah, no, there's tons of positive stuff. There's two aspects to that story really. There's a cultural one and
Mhm.
there's a technical one, right? And if you want to change things, the two things go together.
Right.
And any of our customers have been successful on their API security journey, they've addressed both. Um, let's start with culture. And basically, the culture is to say, okay, we care about security. We're going to give the time for people to care about security.
Yeah.
And one of the things, a few of our customers have been doing is to put like a security, train somebody within the development team to become the security champion, right? And put in place a culture of reward. And that's also very important. Not a culture of, oh, there is this bug, you did it, right? But the other way around, which is okay, we're going to give you tools, they're going to help you enhance things. They're doing hackathon, they give prizes to people who are finding the most problems or have the less issues found by our tools, so all kind of inventive things to make this part of the developer journey. And
Mhm.
really, um, if people ask for time to investigate and find the security issues, make sure it's given to them. Okay, so that's the cultural part. Because if people care and you tell them, "I know, and that's okay, we'll find it later," then then people say, "Okay, well, then nobody cares. Why should I care?" Right?
Yeah.
So that's very cultural.
Okay.
And the other one is the technical. It's back to the tools. It's like, well, that's our customers. They've put in place our tools that give them this ability for developers again to really work from within their IDEs to find their problems, to get automatically educated because we give them all those knowledge databases that they can learn from. Really, the not only telling them, hey, we found this thing here, but
Mhm.
also telling them, hey, we found this here, and this is why we're doing that test, right? We're doing that test, and because it's related to that and that and that and that problem, right? So that people learn, and basically, we have a tool that scores security, and whenever we do a proof of concept with people, so don't be scared, right? Chances are this number is not going to be good for you, right? Like it's going to be bad. And in 95% of cases, and I'm gentle, it's usually between, so it's a score over 100. Okay.
Mhm.
You know that
I
people
use
get
it.
between 2 and 15. That's where
Oh,
our
really? I
90.
don't feel so bad now.
There you go. That's where our 90 percentile is. It's around two. I only know one company, it's a Spanish company. I've been, so because I live in Spain and, but it's the only company I know that when I did a POC with them, their score was straight up at 65, 70, 75 on the first run.
That's amazing.
That was amazing. I thought you guys are the best. So but so making sure now the reward is okay, you got 5, you got 10, but let's see how we take your hand and bring you up to 70. And then, as I always say, my goal with this tool is, as people progress with our platform, instead of starting at 5 and 10 because they're learning, they start at 50 or 60, etc., right? So that the security posture is actually much improved, and we can kind of prove it because that number is kind of going up as people use the platform, right?
I actually recommend this to clients a lot. It's the IDE plugin that's available for in my choice VS Code, but also IntelliJ and Eclipse, which are also
Yeah,
equally good IDEs. I just am used to VS Code,
yeah,
and it's free, right? It's
yeah,
still
it
free.
is.
Yeah.
That's
So listeners, feel free to go play the game. I got 27 and I thought that was abysmal, so I'm feeling a lot better now on the first scan. And I didn't write it, I was just securing it, but we got up into the 60s and I was really impressed.
There
And
you
the
go.
red squigglies led us to victory.
Yeah, and there is one thing is so 42 crunch or not, right? And I'm sure you're gonna agree with this. One of the main mistakes we still continue to do in security is we trust what comes our way, right? So we receive some data, whatever it is. Zella, sure, like, Tanya is writing the application, so that's okay. I'm not going to validate that data. What for? It's taking time and resources, right?
Don't
But
trust Tanya.
don't trust Tanya, don't trust anyone. That's my thing. I didn't used to be in security, but I've learned to become paranoid with that job. It's but seriously, it's just anything. If you don't want to be in trouble, right? Most of the problems in injections, like data coming in, you have to validate absolutely any piece of data that comes inbound, and also you need it to validate outbound to make sure you don't leak data. But inbound, and when I'm saying anything, it's really, really anything. It's not only the payload, it's all the headers, it's JSON web tokens. That's
Yeah,
very important. This is emerging as a problem, right? You
yeah,
guys using JSON web tokens, don't blindly consume them. Just looking at the signature, look at, is this the data I'm expecting? Does it have everything it should be? Like anything coming your way. Remember our friends, from Apache struts and everything around it. It was just the content type header. That was it, right? Containing this huge injection. If somebody in that code had made sure that content type can only be a content type, a MIME type, like application JSON, application XML, or whatever it was,
yeah,
all this mess would not have happened, right? So it's so the back to the score. So I'm linking this to the score. Is most people lose a lot of points in that scoring on the fact that their data they're defining is extremely loose, right?
yeah.
So everything is a string. Yeah, right. But is that a small string, a big string, what, an email, a credit card number, or an account ID? Tell me what it is. Because if you validate, so again, we do validation based on that. But if you have an API management solution, right? Let's
Mhm.
say, in 90% of API management solutions today, you can put a policy on that will say, validate my inputs based on the schema that comes in my open API. Most people will do that. Okay. Well, that schema is wrong. Like you
Yeah,
validate your data
yeah.
against something which is completely loose. You do validation, but it's useless. Well, it's not useless completely, but I mean, if
Oh,
you just say this is a string, the only thing the system will be able to validate is
is that
that,
it's green.
well, it's a string. It's not. So if you wanted to be smarter at validating things, you have to make schemas and describe your data in much, much more detail than we're used to do. And this is why most people get this very low score, is because data is very, very poorly defined, you know.
I have explained this many times. I'm like, listen, if you have a username, it's probably somewhere between 5 characters and 50 characters, right? And they're like,
Yeah.
yeah. I'm like, I'm a jerk. I'm going to put in 5,000 to start. And they're like, why would you do that? I'm like, because I'm evil, Tanya, and I'm testing your thing, right? I'm like, evil Tanya's going to try to put stuff that's not a string. She's going to try to put stuff that's not a string, but like URL encode it first. She's going to be a total jerk.
Yes.
And so I try to explain like all of the things, and they're, oh, but why would someone do that? I'm like, because they're evil. Right? Like, don't think of the normal user. Think of like, imagine I grow these big horns on my head and I've become the devil version of Tanya. I'm the evil one. And I'm like, don't imagine the nice normal user. Imagine the worst case terrible user. Someone shows up at your house party and they're already drunk and they're breaking things and they're yelling. That's the person that's using your app. Someone you don't want to invite over.
Exactly. And what I was always tell people is like, okay, why would a hacker, like, what would Tanya do this? Because she wants her API to break, right?
Yes.
She wants her API to break, so some exception is being raised. And an exception, if you don't handle it properly, it's going to be returned to the hacker. And now, juicy information in the exception. Node.js is being used, MongoDB is being used, whatever it is that you're, filtering out. And then what do? You go to Metasploit, you go to you say, okay, automating injections for Node.js, run. And that's it, right? So nobody's going to read the documentation and play by the book. On the contrary, they're going to do everything but what's in the book, right? Which is why you have to do all this testing. That's what I call the hacky path, right? People test the happy path, so if you put the right data, you get to 200. Yeah, everybody happy. All right. Now, this is one test. And I always tell everybody when I do a conference is I want you, for every happy path test, you should have 10 hacky path tests, which is, hey, what happens if I'm sending something which is not following that regular expression, or 5,000 instead of 10. What I see people doing in our tool is I don't know what the limit is, so they put basically they put max int 64 in 64 max, so like two, like this big number with like, it's like, guys, if I'm sending you this, are you sure your database is not going to explode? There's no way. It's like you say account ID. Okay, let's put 5,000 if you don't know, but don't put 2 to the 64. It's like crazy. That's not
Yeah,
possible. That's not
it's huge.
possible. With some reasonable limits. I'm sure you do have a reasonable limit. So it's all common sense in the end. But it's a lot, this is the hard part. So we're laughing, we're making fun here, but the hard part is it is a lot of details, because not only do I have to care about what I do in my code, the limits I have in my code and things, that's one part of the story. But API security is much bigger than that, right? There's my code, but now, I'm using some libraries that I'm importing from who knows where, right?
Yeah,
Um, I'm using Dockers and I have container images that I'm taking from who knows where. And so controlling that stack is really, you were telling me the other day, SCA, supply chain security is really critical. But that's because we're back to that microservices and explosion of things. And
yeah,
every single atomic microservices come with its potentially its own, like, whatever, a Python image and a Java one and a C one, and one is Alpine Linux and another one is BusyBox and another, and you have to control all of those things to make sure you don't have any known CVEs. Again, if you don't automate any of the validation of those things, exactly.
yeah,
That's the problem. That's the problem. And but you have to, so that's the thing, is you really have to think about all those layers, right? So an app is made up all those layers. And now you're deploying this on Kubernetes, but you have to watch about Kubernetes security as well. So you have all those layers, and all of that is really API security. It's not just that little piece at the top, which is your code. It's that entire stack, which is what really makes it very complicated, right? Because if you, yeah, you have to control all those like moving parts across dozens of different frameworks and images. And so I have some customers, going back to the customers we have, I have some customers that went to very, very stringent, maybe you would say, too stringent, but frankly it's their way to protecting themselves, where, well, you cannot use Docker, you cannot import any library that has not been vetted, etc., etc. But it gives them a single point of control where,
yeah,
someone decides, okay, we're going to use library 1.2 from this thing and 5.5 from this one. It's going to be in our own repository and our own like artifactory or something like that. And
yeah,
basically developers can only use, or ops can only use, what has been vetted in that central place. They are completely forbidden to import anything from the outside world. And sometimes, it it blocks them in their work. It slows them in their work. But
yeah.
frankly, it's a price to pay for having that control, which is really difficult in very large companies. It's very
It
complicated.
is.
So
It's so
yeah,
hard. It's a
it's
new
hard.
mindset. Like
Yeah, it is.
I So it is a stereotype that Canadians are very polite, and I was pen testing a system for some Canadians, and I'm a Canadian, so I can make fun of us. And the responses, Isabelle, were so polite. Oh, your syntax is wrong. Please just change it like this. And they helped me form the SQL injection that I put in my report by giving me all these helpful error messages. And I was like, no, only computers are talking to APIs. Don't give me a nice error message. Stop being so polite.
Yeah, indeed. Well,
So
it's hard, like error messages. You could do an entire session, a podcast on how to write proper error messages and logs, you know?
yes. But I have one more thing before I'm going to try to wrap up.
Sure.
Okay, I have two. So one, could you please invite everyone to your webinar?
I can invite everyone to my webinar. So talking DevSecOps, right? We have very, strong, I would say, integration within the GitHub ecosystem. So on July 13th, so if you go to our website, 42crunch.com, right? On July 13th, we're going to just do basically a 1-hour demo of all an end-to-end putting in place DevSecOps between and using GitHub Actions, Azure DevOps, and how to automate all this security across the entire lifecycle. All live demo.
And a link's gonna be in the show notes. So if you're watching this on YouTube, just go down to the words that are below the video and click show me more and it'll be in there. And if you're on the We Hack Purple website or on Buzzsprout or anywhere else where you're listening to the podcast, just go to the show notes section and a link will be there. But you can also go to 42 Crunch, that's for the number 4, the number 2, and then CRUNCH. And is it .dev or it's .com? COM.
Yeah.
Perfect.
.com. Yeah.
I was also wondering if you could give us just a tip or some advice on, so it seems like managing sessions and authorization, like which access people should have, it's many of the OWASP API security top 10. This is a big problem. Is there any best practice or a piece of advice that you'd want to give people when they're besides test, like any best practice or something you want to tell us?
That's one. So there's 2 different things, right? So authentication, I get this question. I was in a conference last week and somebody came to me and asked me the same question. So which authentication do you recommend? And I always say it depends, right? Because again, it depends on what your API does, and everything comes with a cost. It's like putting security on your door. If you put 10 locks, it's more secure than if you put 1. But of course, the price of opening your door is higher, right? It takes more work to open your door and to close it. So, pretty much in the API world today, the recommended way, there's 2 main things people are using. It's an API key, right? And it's OAuth. So in one case, an API key, it's a great thing. It's very easy to use, very easy to generate. You go on the portal, you give people a key, they put that into a header, in 5 minutes, job done, right? With very limited implementation from a consumer perspective. But this is a hard-coded thing, right? That doesn't move. So I have a $1 million question for you, Tanya. What is the most important repository in the world for API keys?
Oh, is it GitHub?
Yes.
It shouldn't be, but it is.
It shouldn't be.
I don't want it to be. I'm like, oh no, I was hoping I was wrong.
It's such an easy mistake to make, to basically put the API key as a sample or anything in your code. It's why you have GitHub doing things like secret scanning to find those keys, which are put in the code automatically when you actually check the code. That's why they wrote this thing, because it's permanent. So the alternative to that is creating something which is actually not permanent, which is something you just generate on the fly that can last for a number of minutes, or maybe 30 minutes or 1 minute, whatever it is, which is OAuth, right? And it allows you also to authenticate the users and depending on the way you're doing this at a very high level, right? So those are the 2 things. There is something which is API keys, easier to use, less secure in terms of having this key which is traveling over the network again and again, right? OAuth, you still have a token you generate that travels across the network, but at least, let's say it lasts for 5 minutes, right? So you have a hacker will have this 5 minutes window to abuse your system based on that token. It's still not perfect, of course, but it's less than if they get an API key and get free beer forever, right? As we were saying before. So, and there's one thing that's emerging and I see a lot, which is using digital signatures. We were talking about SOAP before, we were used to do this a lot in the SOAP world, which was to sign and to encrypt, right? And so in the REST world, there is this pattern to say, okay, we'll use an API key, so we'll generate a symmetric key. I have a key, you have the key on the other side. But rather than having to send that key over and again, what we're going to do is I'm going to sign the data I'm sending to you with that key, and you're going to validate that signature with the same key in a symmetric way. So we're still using something simple. It's a bit more complicated for the consumers because they have to generate a key, they have to attach it to the request, blah, blah, blah. But there is more and more, support for this. So that's authentication. and actually, I'll give you another link that I'll send on the presentation I did on this, so people have that as well. On the authorization front, the key thing really is this all authorization, put it outside of your code. That would be my main recommendation, you know? So any authorization decision that has to be taken, like, does Isabelle have access to account 123 in Get, as we were saying before? Put that outside of your code. First of all, it will scale better. You'll have an enforcement point you can call from multiple places. And if you need to change that rule for any reason, it makes it very easy than if it's deep down inside your code and people have to go and look for where those authorizations are actually taken. So this is a pattern that I'm recommending to everyone for a very long time now, is to externalize all the authorization decisions from your core code. You know, think about it, but externalize it.
Nice. Will you invite everyone to apisec.io?
I can do that too. So what is APIsec.io? So actually, when we started this company, it's one of the things we wanted to do was to really educate. And so this is like 4 years in the make now. APIsec.io or APIsecurity.io, very easy. It's just a newsletter. It's a weekly one, and it's not 42 Crunch marketing or products or anything like that. You can attest to that. It's really about, okay, the breaches of the week, and we have some. We usually have one every week that we can talk about and describe, unfortunately. Some tools that come out, or books, or anything that can help spread the word and educate people around the topic of API security. So come join. If you want to leave, you can leave at any time, of course, if you don't like it, but I'm sure you will. We have 15,000 people receiving this every week now. So
Oh, that's amazing.
yeah,
Well,
it's
you're going to
great.
have 15,001 now, so.
Absolutely. I trust
And
that.
and your webinar is July 13th, and people can sign up at 42crunch.com.
Yes.
Okay, so we have to wrap up now, and I'm sorry I kept you longer than I was supposed to, but
No.
and I'm like, oh, I want to talk to her for 4 more hours, but I know it's not reasonable. But where can people find more Isabelle? Like, can they find you on LinkedIn or anywhere else?
Yeah. Just Isabelle Mauny, Mauny. So I'm French originally, so it's a French name. Yeah, happy to chat. Isabelle at 42crunch.com. That's my email. If you want to send me an email and talk, happy to do that too.
I can attest to her being extremely friendly and always being happy to talk about API security. Yes. Oh my gosh. So with that, we are wrapping up this episode of We Hack Purple podcast with sponsor Semgrep. And Isabelle, thank you so much. This was so fun. I really appreciate you being on the show again.
Thank
Oh,
you.
for people that haven't seen, Isabelle also did another We Hack Purple streams last year, and I'll link that in the show notes too, where she gives this big demo of their linter and how you can use it to secure, basically like rewrite your open API definition file. So it's like really tight and like basically you harden it
Awesome.
with the red
Thank
squigglies.
you for your time, Tanya, and for inviting me. Anytime. I'll do another 4 hours with you anytime. Just call me
Okay,
and
you
we'll
heard
do
it,
it.
folks. You heard it. Okay, thank you so much, Isabelle, and
Thank
let's
you.
sign off. See you all next time on the We Hack Purple
And take
podcast.
care, everyone. Bye bye.